Yeah, good day. So here I present to you the code base for this project about how does digital screen time affect well-being. So this project we use the data science skills and techniques learned to discover how digital screen time affects self-reported well-being among a large cohort of adolescents in the country. So, three data sets were provided to tackle this problem to uncover insights from this problem. So, the first data set contains the demographic and some information more than 120,000 adolescent respondents. So, the second data set contains captures the digital screen time spent of about approximately 113 respondents. Then the third one, which is the last data set, describes various self-reported well-being indicators for indicators of 102,580 adolescents that responds to that. So here the first thing we have to do here before we can move on to any kind of analysis, we need to make sure that the data are readily available. We import the data. So prior to importing the data, there are some modules that we need to use. These are the modules like pandas for data cleaning, matplotlib for data visualization, same thing with seaborn, the numpy for numerical analysis, scipy for statistics, and scikit-learn for building our model. So after performing the analysis, we need to build a model to capture or to predict the well-being score of the participants based on the screen time using these three data sets that I listed. So the first thing here we have to do is importing the data, the modules we need, which is this, then followed by importing the data and clean the data. So what I did here was creating a function to read and pre-process the data. You can see here read and process the data. Then I imported these data sets, then merged them into one. So we are only returning records for those adolescent that responds to the three stages of the data set, which is the first one, their demographic, then the second one the screen time, then the third one is their well-being indicators. So we merge them into one, and then we try to get the well-being score by getting the mean, the average, the average of all of their their self-reported well-being indicators. So we have optimism, we have relaxation, we have a lot of them here. So I am getting the average of these guys to make sure that we have the average. Then after that, I get the total screen time spent by the student. Then that was the data importing and the preprocessing phase. Then followed by that, we have to do some data exploration. So we try to like return some records from the data sets, and then we did the data info by getting, so this is just exploration, trying to understand the data, and then we perform some statistical analysis to better understand how the data is being distributed. Then the next one is we try to perform some analysis. So two investigations requiring descriptive statistics. So the first one is average screen time hours on weekdays. I got the average week time screen time hours on weekdays. So is it gaming? How many hours on average do students spend on gaming? Do they spend on smartphone and the other category? The second one is on weekends. So we try to understand the trends of these two guys, the average screen time spent by these adolescents on weekdays and weekends. Okay, then these are the insights generated. So the average screen time for most activities is higher on weekends compared to weekdays. So this is consistent with the general behavior of adolescents who likely have more free time on weekends and thus spend more time engaging with screens. So we have to perform two inferential statistics as well. So inferential statistics is just like a statistic that we use to make inference, right? So here the first one I did here was assess if there is statistical significant difference in screen time between two groups of adolescents, which is the male and female. So I did the first one here, then I got the t statistics. So I perform an hypothesis. So this hypothesis gives me that the negative value indicates that average screen time on weekdays for male is significantly different from females. So they spend different time on screen times. So and then the p-value says that we have extremely low p-value, which is far from the standard threshold of 0.05. So this indicates that the difference between males and females in terms of screen time on weekdays is statistically significant. So after that, the second one we performed is examining the relationship between screen time on weekends and adolescents' well-being relaxation. So what effect does spending time uh, on weekends with your smartphones or other things, other screens, does it affect relaxation? So we have got the coefficient, correlation coefficient, and the p-value here. So the result of the coefficient is that there is a weak negative correlation. As smartphone screen time increases, there is a slight tendency for relaxation to decrease. Okay, then the p-value indicates that the relationship is statistically significant, meaning that the observed trend is unlikely due to random chance, so it doesn't always seem to happen. So then the last phase is building the model. So we build the model, we train the data, we split the data into training and testing sets. You can see here training and testing set. Then we use 30% of the data to test, then we do some standardization here, and then we initialize our linear regression, we fit the data into linear regression for training, then this is our prediction, then this is our mean squared error to get the error. How does the predicted value deviate from the actual value, then the score, which is the accuracy score of our model, then we return the mean squared error and the accuracy score. Then this gives us a mean squared error of 8%, which is good, and accuracy score of 85%. So the linear regression model predicts well-being score based on demographic factors and screen time data, performed well with the following key results. Mean squared error 8%, indicating that the prediction were close to the actual values. Yes. Then last but not the least, 85% accuracy, meaning the model explains that 85% of the variance in well-being score, suggesting it predicts a strong predictive accuracy. So that is all about this project. Thank you.